All right, friends. So what we're going to do now is we're going to look back at the PowerPoint from class, and we're going to get some applications that I have on that PowerPoint that'll help us kind of put this spreadsheet to work. This spreadsheet's really nice in that it does all the math for us, but it's really good to see the ins and outs of the data going into the spreadsheet to really appreciate. Like, for example, how often are you going to see a road that rises 5 for every 12 that it runs? I can tell you right now, probably never. Because a 42% grade is not a road that exists, as far as I know, anywhere in the world. And if it does, it's some rattly backcountry road that's probably too unsafe to drive on anyway. But nonetheless, there are ways to use grade with more realistic applications, which we're going to look at now. So I'm going to your web page here, your Math 105 Math and Society page. I'm going to go to the resources page. And I'm going to go to the PowerPoint from the grade topic, which is that's what we were working on in class. And you're going to recognize this. It takes a little while for it to download. Whoops, it's over on this side. Apologies. This isn't going to load very well, unfortunately. I've got 2 monitors, and I can't get this thing when I click the preview there. It's actually showing up on the other monitor, and for the life of me, I just spent 15 minutes trying to figure out how to capture the other monitor, and I've decided that I don't care. So we're just going to use the pictures over here from this one. I wonder if I can just zoom in and get. That's probably a better idea. I'll just zoom this in. I wonder if I can just close this. That's going to be just fine, I think. So, at any rate, we've got lots of these pictures that we played with in class. All wonderful grade calculations, percentage grades. Lovely, 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 lovely. That was the last one I think we looked at in class, which was our dear friend riding his bike up the 37% Canton Road in Pittsburgh. Just insanity to think about. Although I wouldn't want to think about going down the damn thing, which would be even worse. Now, I didn't look at this one because, as somebody asked in class, is that photoshopped? And I'm sure it is, but my lord, if it isn't, ridiculous. These are simply references back to the maps we did in class. So this is what I wanted to start with right now, is a few images from one of my favorite places in Oregon. This is the Mackenzie River Trail. These are some images. That's Blue Pool. That's Haley Falls. That's just riding a bike over one of the many, many bridges. That's the beautiful bridge next to the river. It's a beautiful section of Oregon if you've never, ever explored it. It's out on, I guess it's 20 or 22 out there as you're heading kind of towards Salem, but then you turn towards Eugene. Clear Lake is the beginning of the Mackenzie River, and it's a beautiful, beautiful way to spend a day if you ever get a chance. I like doing the bike ride with my family, and so what I've got here is I've got an actual Geo Tracker output from the Mackenzie River Trail. So what I do with this one is you start your Geo Tracker when you start at mile 0, which would be at Clear Lake. And then you stop it when you end up down at the end of wherever you decide to stop riding the trail. This one stops at Mackenzie Bridge. Okay, you can also stop at Paradise. You can go down as far as you want, really. And it's funny, whenever I talk to my wife about doing this ride, she always complains about the Mackenzie because of the uphill section. And she's referring, of course, to this little bit right here, where there is a little tiny bit of very steep uphill in that section. We'll come back to that one and look at it later. But my question is, what is the grade of the Mackenzie River Trail? What is the grade of the Mackenzie River Trail? So it's obviously tilted, but it's not uniform, right? It's not uniform. It doesn't drop uniformly the whole way. It does drop predominantly in one direction, down, except for these little tiny hiccups where it goes uphill or flat. But it definitely does predominantly drop. And as a matter of fact, I don't know if you can see it. I'll zoom in. If you Google Mackenzie River Trail elevation, I got the following result. Trail begins at an elevation of 3,200 feet and ends at an elevation of 1450, excuse me, as it meanders along the banks of the Mackenzie River. It's totally awesome. Okay, so how much elevation do you drop? Or if you're going the other way, how much elevation do you rise? Well, if you start at 3,200 and drop to 1450, the difference of those two has to be what you end up dropping. Okay, now I'm going to show you something fun in Excel. 3,200, 1450. That's your rise. If you want, you can actually just type that math into Excel. Equals 3,200 minus 1450. Make sure you put the equal sign in front there. That means it knows it's a formula then. When you press enter, it will tell you that means you dropped 1,750 feet, which is exactly the change you would get if you simply subtracted 1,450 from 3,200. Okay, so far, that's your rise, or in this case, fall, but that's all relative to what direction you're going. Now, you might notice that the Excel spreadsheet is currently telling you that the angle formed is 89 degrees, almost 90 degrees, and the grade is 14,583. That's because the run is technically left at 12 feet. Now, we know for certain that we are not running 12 feet. We are not running 12 feet. Go back to here. What are we running? Well, I want you to think about this now. Okay. Whoops, I hit the wrong button. Apologies. I gotta get the zoom button. Okay, I'm gonna zoom out. There's the elevation gradient. So we just calculated the distance here, which was the 1,750 feet. Now, the run, quote unquote run, is going to be from 0 to whatever the end of this map is. Now let's just do a quick check here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Looks like it's stopping at just above 24 miles. We can call it 24 if you want. So now I want you to think about two things. First of all, is that the run or is that the road? Think about that for a second before we answer. It's got to be the road because it's a tilted surface on Earth. It's a tilted surface on Earth. If you go back a slide, the picture of these folks riding on the trail right here, they're not riding horizontally. They're riding on average slightly downhill. If they were riding horizontally, that river wouldn't be a river, it'd be a pond because the water wouldn't be flowing downhill. So since they're tilted, they're heading down. So this yellow line is the road, which means this distance is the road. Which means, if we go back to our spreadsheet, we have to take the run out and replace it with the road. Now I'm going to put something in here, and I want you to think about why it isn't completely correct. I'm going to put 24 in there. I'm going to press enter. Okay? Now the first thing it's going to do for you is it's going to give you a bunch of errors. It does calculate the wrong way grade at 7,300%. And hopefully you're realizing the problem right now. Hopefully you're realizing the problem. The road units are in miles. The rise units are in feet. Go back and look again in case you don't see that. These are in feet, and these are in miles. That's a problem. We need to have the same units when you do a grade calculation. So we have two choices. We can convert miles to feet, or we can convert feet to miles. My personal opinion is going to be we're going to convert miles to feet. That's my personal opinion. So what you have to know here, this is also a preview of your next project. To convert miles to feet, you're going to do equals 24 times, and you have to know how many feet in 1 mile. That's 5,280 feet. So you do equals 24 times 5,280, press enter, and it's going to convert the road to 126,720 feet, which means the grade, either calculated the right or wrong way, is right about 1%. On average, it's right about 1%. That is hardly any tilt whatsoever. That overall average grade of the Mackenzie River Trail. Now, some of you might be looking at this graph and going, that looks a lot steeper than a 1% grade. That's because the scales are not consistent here. These are in feet, which means that this little unit right here is 500 feet. That same unit right here is 1 mile, 5,000 feet approximately. So in other words, this distance here is 10 times bigger than this distance here. Relatively speaking, I'm rounding off here. So that does look a lot steeper. It would look very, very boring if it was drawn to scale. It would basically be almost a perfectly horizontal line running left to right. But the reason they scale it like that is because, I mean, that is huge compared to that right there. Okay? So either the right way or the wrong way grades are basically the same. They both round to 1%. Let me see if I can get a few more decimals here. There's the right way, here's the wrong way. Now let's see how many decimals we have to go out until they show as different. There you go. If you go out to 3 decimals, you can see the wrong way and the right way grade differences. The wrong way is a little bit less, and the right way will always be a little tiny bit higher than the wrong way grade. And we'll ask you again why later on your first exam, why that has to be the case. But for right now, don't worry about that. Just realize that the right and the wrong way are exceptionally close. As a matter of fact, the percent error is showing at 0. It's not really 0. It's actually, it's 0.01%, which is extraordinarily small. But the idea being is that in this particular case, whether you calculate it right or wrong way is irrelevant because the calculation is exactly the same. Hopefully that makes sense. I want to look at it one more time to show you why my wife actually does have a point to some degree. She complains about this trail sometimes because of this uphill section. Even when we're going downhill, she complains about this crazy uphill section right here. So what I want to do is I want to look at not the average grade of the entire trail, which we just calculated to be 1%. I want to calculate Jen's hill right here, Jen's little hill. So I want to look at a couple things. First of all, that looks like it's about, let's see, if I drop a vertical line down from here, it looks like it's just about at 11. And if I drop a vertical line down from here, it looks like it's just about at 10. So it looks like this is about a mile of a climb, about a mile of climb going from here to here. So let's keep that in mind, 1 mile. How about elevation? Let's superimpose this over. If I come across to here, that top of that right there, I'm going to guess that's about 2,400. And the bottom of this, I'm going to approximate that at maybe 2,100. So that's 300 feet of elevation gain that Jen has to deal with. So I'm going to come in here and put the rise at 300 feet. And I'm going to put the road at 5,280 for 1 mile. Hopefully that makes sense. Okay? If you actually calculate that, the grade of that hill is about 5.7%. If I could get fewer decimals, we'll round it off to 6. So either right or wrong way, both rounds to 6%. And again, there's almost no difference in the calculations. So 6%, that's college way. So I think my wife has a point. When you look at that little tiny section of Mackenzie River Trail, the grade is an uphill 6%. Whereas if you look at the entire Mackenzie River Trail from beginning to end, it's actually a negative 1% because you're dropping over that entire distance. So at any rate, the most important thing, there's 2 important things to take away from this. Number 1, make sure that your units agree in the rise and the run or the rise and the road. Both of these were rise and road. And secondly, make sure that you recognize when something is a road versus a run. Generally speaking, you're almost always going to have the road, unless you can do like we did in class with the rulers and measure the stairs. So there you go. There's your introduction to grades. I'm going to have you, for practice, calculate the grade. If you go a little bit further in the PowerPoint, if you go a little bit further in the PowerPoint, I have a slide in here, which is a day me and my friend Bill took our fat bikes out to the Winoga, not Winoga, we went out to Dutchman Flat, and we started at Dutchman Flat. And then we rode our bikes all the way to Elk Lake, all the way down to Elk Lake. And I want you, for practice, to figure out about what is the average grade of the Cascade Lakes Highway from Dutchman Flat all the way down to the Elk Lake turnaround where we turned back around. It was a wonderful day. It was about 31 degrees. The whole ride down was absolutely gorgeous. It was all downhill, first of all. About 10 miles all the way down there. Actually, it was more like 12 miles, if I remember correctly, all the way down. And then coming back, it got warm, it was getting sloppy, and it was all uphill on the way back. So that same grade we rode on the way out, we had to turn around and repeat on the way back. Great day, nonetheless. So give that a shot. Try to calculate the grade on that one. If you get stuck with it, then bring it to class on Monday or Tuesday, and ask me, and we'll get it answered. All right. Hope that helped, and we'll see you soon.